before we can actually understand more of the very important discoveries that our three laureates have made, we need to maybe remember a little bit about how actually a battery operates. For example, a AA battery you can see here to the right. So as you see to the left here, this is a simplified drawing of a typical battery. So you can see it contains two electrodes, an anode and a cathode, and those are separated by some kind of electrolyte. It's typically a liquid that can host or accommodate charges or ions. And sometimes you also have a barrier between these two electrodes, so they're physically separated from one another so you don't get short circuits. And what actually happens in a battery is that you have chemical reactions taking place at each of the electrodes. And that generates electrons that can then pass through the circuit, the electric circuit, and power whatever electric device that you want to power. So when you actually look at this simplified drawing here, it may look relatively easy to make a battery, right? However, that is definitely not the case. It's really very, very hard to produce, to design and develop well-working and efficient batteries. And just as examples, some of the batteries we're still using today, like the lead-acid battery and alkaline batteries, they have their origin in the 19th century. So it's really a hard job to make a new good battery. Yet, that's exactly what our three laureates have done. They have taken on this challenge, and their discoveries have led to the development of the phenomenal, fantastic lithium-ion battery. So what is this all about then? Well, as you can see, the name reveals it. This is about lithium. And to the left here, you have a small piece of the periodic table, and you can see that lithium, the red box, has atomic number 3, and it's a very small element, and it's actually the lightest metal we have. And it actually floats, at least temporarily, on water, if you would try that. And that is a very good and attractive kind of property of lithium, because that means that you can pack lots of lithium atoms in a battery, and you still have light weight and a small volume. Another property of lithium that is also very good, as you can see here to the right, is that lithium has an enormous tendency to give away one of its electrons. And so you can see that lithium atoms, they have 3 electrons, and it's very easy for lithium to give away one of the electrons, and then it becomes a positively charged lithium ion, as you can see there to the right. However, these are fantastic properties, but there is a flip side. And the flip side, as you heard a little bit from Sarah here, is that it's a fantastically reactive element. So for example, it reacts quite vigorously with water. So in order to use lithium in a battery, you really need to tame its reactivity. And that's exactly what the work of the laureates really have achieved. So how did they actually do it? Well, let's jump directly to the 1970s. So around in the middle of the 1970s, Dr. Stanley Whittingham discovered a fantastic material that can be used as a cathode together with the lithium. And that material, as you can see to the right here, was titanium disulfide. And as you can see a little bit in this zoom-in circle there to the right, titanium disulfide is actually a layered material. So you have layers, and between the layers you have gaps where lithium ions can sneak in and go out freely. And also very, very advantageous with this type of material, it has a relatively high potential towards lithium. So when you put this together in a battery, you can get a quite high potential of 2 volts. That's already quite good for any battery. Remember, some of the alkaline batteries we use today are 1.5 volts, right? So 2 volts is already quite good for a battery. However, during this time, it also became quite evident that lithium metal is not really quite optimal to have in a battery, right? Because you can have problems. So the idea came up how we should replace lithium with something else. And then you have 2 challenges. One is, with what do you actually want? Can you replace it with? And secondly, whenever you replace lithium metal, the potential will come up, meaning that the overall battery potential will go down from, in this case, then 2 volts to less than 2 volts. So now the challenge will be, how do you maintain the battery voltage or even increase it? And that's exactly what happens next. So in around 1980, Dr. Goodenough, he discovered a really phenomenal, fantastic material that could actually do this. And that material, as you can see here, was based on cobalt oxide. And again, as you can see in this zoom-in circle there, this is also a kind of layered material that have gaps between the layers where lithium ions can go in and out freely. And because this is an oxide material, it contains oxygen atoms, then you get a fantastic high potential towards lithium. So when you put this together with the lithium in a battery configuration, you will get an enormous voltage of 4 volts. And this is a gigantic leap in the battery world from 2 to 4 volts. It's a huge leap. However, as you can see here, we still have the lithium metal as one of the electrodes here. But so how do you replace that? And that's exactly what happened next. So in the 1980s, Dr. Yoshino here, he started working on trying to figure out ways to replace the lithium metal. And he started looking at different types of carbonaceous materials. And he found out that certain qualities of, for example, petroleum coke, as you can see here to the left, when you treat it in the right way, also contains this kind of layered structure where you have gaps where lithium ions can go in and out. And furthermore, this material, these carbonaceous materials, had a fantastically low potential compared to lithium. So when you put this together, this material together with Goodenough's cathode material, you can maintain a fantastically high voltage in this particular battery of 4 volts. And this, what you see here, this is the configuration that we have in the modern days lithium-ion batteries. So the way it works is that you have 2 electrodes. Both of these electrodes are materials which can take up and release lithium ions at different potential. So what happens here is that during discharge, you have lithium ions going from one material across the electrolyte and into the other material. And at the same time, you can see that the electrons are passing through the circuit, driving your electric device. And this makes it very safe, because here you don't have any trace of lithium metal. So it makes it much safer. And also, what is very important here is that you can turn this process around. So if you plug this battery into a power source or a charger, you can reverse the process and you can recharge the battery. And of course, this process you can do many, many, many times, hundreds of times before the battery actually degrades or loses its capacity. So you can see that these discoveries really led to the development of a fantastic product, the lithium-ion battery.